We are in section 2.7, the last section of chapter 2 in transformations. And this transformation we're going to talk about is called dilation. We have two vocab words here. A dilation, there's your first vocab word, dilation, is a transformation in which a figure is made larger or smaller with respect to a point called the center of dilation. Now let's think about when you get your eyes dilated at the optometrist or the eye doctor. If you get your eyes dilated, your pupils of your eyes either get smaller or bigger. Most of the time they get enlarged, they get bigger. So when you enlarge your eyes, that is called dilation. You're dilating your eyes. It's the same process when we talk about a transformation of a shape. So write this definition down, and then we're going to draw a picture that will hopefully help you. Here is our picture. We have a center of dilation, which is located right here. And then we have a smaller shape that is enlarged to a bigger shape. Now you will notice that these shapes are going to be similar. They won't be congruent because one is going to be bigger than the other. But they are the same shape. They are different sizes, however. And remember, please remember what similar means. The ratios of all of the sides are the same. So if this had a ratio of 1 to 2, this would have a ratio of 1 to 2, as this side would have a ratio of 1 to 2. So if they're similar, they're the same shape, but different sizes. So I'm going to give you two shapes. You do not need to write this down, but I do want you to pay attention. I'm going to explain more in depth what this means, what these little lines and this point center of dilation, what that means. So I'm going to draw two shapes. So here I have drawn two triangles. Now, if I want to tell if one shape is a dilation of the other, what I'm going to do is I'm going to draw lines connecting the corresponding vertices and see if they meet at a point. So this vertice and this vertice are going to connect them. This vertice and this vertice, I'm going to connect them. And this vertice and this vertice, I'm going to connect. And if you keep going, now this is really bad because I'm on my iPad, but all of these meet at a point. Therefore, these two shapes, one shape is a dilation of the other. This one, the blue shape, is a reduction of the red shape, or you can say the red shape is an enlargement of the blue shape. But they meet right here at a center of dilation. Here is your key idea for dilations in the coordinate plane. Let's first put this into words. In words, to dilate a figure with respect to the origin, you have to multiply the coordinates of each vertex by a scale factor k. Please write down somewhere that k equals your scale factor, or underline it right here. Your scale factor is represented by k. So here's what you do with k. We're going to put this in algebra now. We already talked about words, now we're going to do algebra. Here is algebra. We are going to take the coordinates is x comma y, of each vertex of your shape. And then you're going to multiply each of these coordinates by k, which is the scale factor. So k times x and k times y. Now k, there's two things you need to know. Now these two things are most likely common sense to you, but just to verify, we're going to go over these. When the value of k is greater than 1, the dilation is an enlargement. Think about it. If you multiply a number by a number that's bigger than 1, the number gets bigger. Therefore, the dilation is an enlargement. However, when k is greater than 0 and k is less than 1, that means k is between 0 and 1. If k is between 0 and 1, that means it's a fraction, less than 1. So if you multiply by a fraction, less than 1, your dilation is going to be a reduction, which means your shape is going to get smaller. So let's do an example. Here is our first example. Draw the image of triangle ABC with vertices A, 1, 3, B, 2, 3, and C, 2, 1 with a scale factor of 2. Identify the new coordinates and the type of dilation. So the first thing we're going to do is graph the vertices of ABC. So we are going to make a coordinate plane. Make sure you label the X and Y axis. Put arrows at the end. Alright, so the first thing we're going to do is graph A, B, and C. A is 1, 3. I'm going to label it point A. B is 2, 3. I'm going to label it point B. And C is 2, 1. I'm going to label it point C. So now I'm going to connect the points. So I now have my triangle ABC. Now we have a scale factor of 2. That is your K. Your K is 2. Now if you remember your key idea is you have to take your ordered pairs, A, B, and C, which are 1, 3, 2, 3, and 2, 1. And you take the K and multiply each coordinate by that value. And that's then going to give you A prime, B prime, and C prime. So if you multiply A by 2, 2 times 1 gives you 2, 2 times 3 gives you 6. Multiply B, 2, 3 times 2, it's going to give you 4, 6. And C prime is going to become 4, 2. Now we graph all these. A prime is 2, 6. B prime is 4, 6. And C prime is 4, 2. Yep, let me erase that. Always make sure you draw the best graph you can. And there we have our similar triangles. These triangles are similar. Now I'm going to take this one step further and just kind of real quickly show you this. You don't have to draw this. But if you notice, this is a side length of 1. This has a ratio of 1 to 2. That's 1/2. This side has a length of 2. This gives you a ratio of 2 to 4, which is also 1/2. These are similar. If you remember what similar means, the ratios of the sides are the same. You don't have to do that in this problem, but I just was reviewing what we did earlier in this chapter before break. Now, identify the new coordinates. We did that. Those are these right here. What type of dilation is this? And by type, I mean, is this an enlargement or is it a reduction? Well, because our K value was bigger than 1, this was an enlargement. And those are your two answers. The ordered pairs and the type of dilation. Here is example number 2. The vertices of rectangle WXYZ are below and has a dilation of 1/2. So right off the bat we know K equals what? What's your scale factor? It's 1/2. So you have to multiply all of these by 1/2. Now, prior to junior high, you should already know how to multiply by fractions. You will be expected to multiply by fractions like 1/2, 1/3, 2/3, 3/4. That's review. You should know how to do that. If you don't, you're going to have to look that up or get some help with how to multiply fractions. So if I multiply all of these fractions by 1, or all of these ordered pairs by 1/2, you're going to get W prime, X prime, Y prime, Z prime. If you multiply by 1/2, -4 is going to become -2, 6 is going to become 3. X is going to become -2 and 4. Y is going to become Y prime, which is going to be 2, 4. And Z is going to become 2, -3. Now let's say we had, for example, let's say that instead of 8, this was 7. If this is 7, then this would be 3.5 or 3.5. So you will have decimals or fractions for some of your answers. So now we're going to graph both of these. what I'm going to do, I am going to count by, well, let's say twos. I'll count by twos. Whoop. Let me redo that. Label your x and y. Now if I'm looking here, I have to go all the way up to 4 and -4 and 8 and -6. So that tells you I have to go up to at least 8. So I'm going to count by twos. 2, 4, 6, 8. 2, 4, 6, 8, -2, -4, -6, -8, -2, -4, -6, -8. So I'm going to graph my first shape in blue. So -4, 6, that's W. -4, 8 is X. 4, 8 is Y. And 4, -6 is Z. So my shape is going to look like this. It's going to be a trapezoid. So now I'm going to graph W prime, X prime, Y prime, and Z prime with my red. So -2, 3, that's going to be right here. Then I'm going to do -2, 4, which is right there. 2, 4, and 2, -3. And if we label these points, W prime would be here, X prime, Y prime, and Z prime. So we've identified our new vertices, but what is the type of dilation is this? Well, since K was bigger than 1 and less than a half, that means it's basically between 0 and 1. This is a reduction because your shape got smaller. And that is your answer.